In the previous lesson, we are talking about the vertical asymptote and the holes. In this lesson, we will talk about the horizontal asymptotes. So asymptotes are usually either vertical or horizontal. So horizontal asymptote is again a line that the graph approaches to but never really touches. It's also the y value when it's like kind of one y value that the graph approaches to as x becomes really large or really small. To find the horizontal asymptotes of rational function, you have to have this function of p of x over g over x. Both of them are polynomial function. Then you have to look at degree of numerator and the denominator, and you have to compare them. So if you compare the degree of numerator and the denominator, we have three situations. First, the numerator has lesser degree than the denominator. So in this example, the degree of the numerator is 2, whereas the degree of the denominator is 3. So we have bigger denominator than the numerator. So in this situation, we know that horizontal asymptote is the line of y is equal to 0. We'll talk about why this happens in class, but for now, I want you to just kind of remember, try to remember this rule as much as possible, and then probably just practice how to use it. Another situation is that the numerator has bigger degree than the denominator. So if you look at this example, the numerator has degree of 3, and the denominator has degree of 1 because it doesn't have any exponent here. So in this case, when the top is bigger than the bottom, the horizontal asymptote does not exist. So there's no horizontal asymptote. The last situation is that they have the same degree. So the numerator has degree of 2 in this case, and the numerator has degree of 2. So they have equal degree. Then the rule is that the horizontal asymptote is y is equal to a over b. So a number here means the leading coefficient of the numerator, which is 5. That's the leading coefficient. And the b number is again the leading coefficient of the denominator. So the leading coefficient of the denominator is 2. So the horizontal asymptote of this graph will be y is equal to 5 over 2. 5 over 2. So let's just kind of take a look at their graph, each of them, to see if that's really true. So let's look at the first graph. According to our conclusion, the horizontal asymptote must be this line, y is equal to 0. Okay, this one. So what happens in the middle here, it doesn't really matter. Horizontal asymptote is what happens at the very far left and far right of the graph. So if I just zoom in the graph a little bit, you can see that the graph kind of flattens out as it goes to the right and goes to the left. So we can just click maybe random point here. So it says that if when x is 45, y is 0.06. It's almost like 0. So you can see that the graph approaches to 0 but never really reach 0. So in this case, our horizontal asymptote is this line, y is equal to 0. Let's look at the second graph, second function. According to our rule, we shouldn't have any horizontal asymptote. And if you look at the graph, that's kind of true because the graph doesn't really flatten out. It goes up and down vertically. It may have vertical asymptote or vertical hole, but it doesn't have any horizontal line that the graph approaches to. The last one should have the horizontal asymptote of y is equal to 5 over 2. So you can see that the graph flattens out when it goes to the right and left. So let's just zoom in a little bit to verify. So you can see that it's almost flat. If I click point here, when x is 50, y is like 2.44, which is almost 2.5. Right here too. When x is 100, y is 2.47. Same thing happens on the left side too. Except on the left side, y values are really slightly above the 2.5. On the left side, y values are slightly below 2.5. So let's look at the example on our handout now. Figure out the horizontal asymptote. So let's look at this one. What is the horizontal asymptote for the rational function? So you look at the a function. 2x is equal to 2x over x minus 3. So now you compare the degree of the denominator. So degree of the denominator is 1, degree of the numerator is 1. So that means they have the same degree, which means we have to follow that rule. The leading coefficient of the numerator in this case is 2, and the leading coefficient of the denominator, which is 1. That's 1x minus 3. So y is equal to 2 is the horizontal asymptote. Let's look at b. The degree of the numerator is 1 and the degree of the denominator is 2. So when you have bigger, heavier denominator, you follow that rule. So when you have bigger degree in the denominator, the rule is that y is equal to 0 is your horizontal asymptote. Okay, the last one. Degree of the numerator is 2 and the degree of the denominator is 1. So numerator is bigger, top is bigger than the bottom. That means this is a second case where there's no horizontal asymptote. So we can just write none. Okay, let's look at more complicated example. This is about how to graph the rational function finally. So we were talking about how to find vertical asymptote and whole, also horizontal asymptote. With these tools, we can just kind of guess general shape of the given rational function. So this is a typo. I guess there should be y is equal to. So step 1 is first find the horizontal asymptote using the rule that we just talked about. So we're gonna compare the degree of the numerator and the denominator. In this case, they are both 2. So that means we're gonna follow this rule, mean y is equal to a over b, the coefficient of the numerator and then coefficient of the denominator. In our case, coefficient of the numerator and denominator, they are both 1, so it will y is equal to 1 over 1, which is y is equal to 1. So that's the horizontal asymptote. So I'm just gonna graph the horizontal asymptote right here. Y is equal to 1. And then second step is find the point of discontinuity. So discontinuity is again vertical asymptote or whole. It can be either, depending on whether the factor is being cancelled out or not. So to find the point of discontinuity, we have to look at the denominator. We have to factor that to see if anything can cancel out. So x squared minus 4 is equal to x minus 2, x plus 2. And the top can be factored to x plus 4, x minus 3. The reason why I factor is so that I can check if any factor can be cancelled out. In this case, we cannot cancel anything. That means these two factors all become the vertical asymptote. That means we have two vertical asymptotes. One is x is equal to 2 and x is equal to negative 2. So let me just graph these vertical asymptotes, two of them, this and that. Okay, so now we know vertical asymptotes and one horizontal asymptote. So the third step is find x-intercept and y-intercept. We just want to find these points because they are kind of important points for any function. The rule for finding x-intercept for any function is you set y is equal to 0. In this case, if you set y is equal to 0, you will have this situation. If a fraction, the value of fraction equals 0, it's always going to be the top number is equal to 0, right? Because the bottom can never be equal to 0, and if the top is 0, then the value of the fraction becomes 0. So that means we just gonna set the top equal 0. X squared plus x minus 12 is equal to 0. We know from the previous factoring this is equal to x plus 4, x minus 3 equals 0. So if this is true, then x must be negative 4 and 3. So that's your x-intercept because you set y equals 0. So x equals to negative 4 and 3. These are the 2 points that the graph must pass. Okay, to find the y-intercept, you set x equals 0. Now from that function, if you set x equals 0, you're going to plug in 0 into x. So if you plug in 0, you will get 0 plus 0 minus 12 equals 0 minus 4, which is negative 4, which end up being 3. So 3, this point is your y-intercept. And then last step is to plug additional points because we're not really perfectly sure what the graph looks like. So maybe I can plug in 1. If I plug in 1 here, I'll get 1 plus 1 minus 12 over 1 minus 4, which is negative 10 over negative 3, which is 10 over 3, which is around 3.3. So when x is 1, y is 3.3. So it seems like the graph increased this way. Because we have vertical asymptote here, the graph cannot pass here. And then we can just assume that it's gonna look like that. So graph will look something like that. This is just kind of rough estimation. For this lesson though, it's enough to have just rough estimation only. So that's how you graph based on our knowledge on the horizontal asymptote, vertical asymptote and whole, and the x and y intercepts.